Hey guys, in today's video we will be covering about DW function for numbers and binaries. So I will be covering almost all of the functions over here which are being supplied from DW core numbers and DW core binaries. So without any further ado, let's get started. So as you can see my screen, there are a couple of examples which I have already mentioned over here. So this is particularly for the number conversions. Number will be converted into binaries, into hexa, and from hexa to again into the normal decimal, into the decimal format. And then we will be using the radix number to convert any decimal number to a different number system and vice versa. So let me show you the preview as well. So you have to first make sure you are importing the functions according from this DW code numbers. If your requirement is specific, then you have to pick up the specific function only, like import to binary from DW code numbers or import from binary. But I will be using all of these functions, so that's why I have mentioned star from DW code numbers. Now let's start with the binary operations. So 1, 2, 3, 4, 5 is a decimal number. When it is being fed to two binary function, it gets converted into binary format. So 1, 2, 3, 4, 5 in binary is being represented like this. Now, just to showcase, like if we pass a null in a two binary function, it returns null. If we pass 0 or -1, it returns 0 and -1 respectively. So this was about the conversion from decimal to binary. What about to cross check it? So I have just copy paste this particular 001 to the from binary argument, and you can see the conversion is the same as 1, 2, 3, 4, 5, which we are trying to convert to the binary in the first function. So with this, to and from binary functions are completed. Now let's jump to the hexadecimal conversion. So 1, 2, 3, 4, 5 is being converted to a hexadecimal using two hex function. So here you can see 3039 is the hexadecimal equivalent of decimal number 1, 2, 3, 4, 5. Similarly to null 0 and -1 behavior of two binary, the same behavior is being applicable for hex operation as well. So when you pass null 0 or -1, to convert to the hexadecimal conversions, you will get the same 0, -1 and null respectively. In order to cross-check whether this 3039 is the correct hexadecimal representation of our decimal number which we have converted, I have pushed down this 3039 to the from hex function. So as a result of this, the from hex is being returning me the same decimal number which I have converted it into the hexadecimal onto the line number 30. So this was all about the hex operations. Now, if we want to convert any decimal number into any number system, or let's say binary or hexa. So radix number, two radix number gives us that functionality in which we can pass two arguments. The first argument will be the number and the second will be the number system, or you can say binary or hexadecimal representation. So line number 21 converts 1, 2, 3, 4, 5 into the binary equivalent of it. So you can compare this one and this one. These are exactly same. Basically 1, 2, 3, 4, 5 is being converted into the binary equivalent using the radix number function. Similarly, 1, 2, 3, 4, 5 is being converted to the hexadecimal position using the two radix number, and you can see 3039 is the output, and same can be confirmed from this 2 hex output as well. Similar to that, once it has been converted to radix number, maybe it is a requirement like we have to revert back to the same original decimal format. So for that, there is a function named as from radix number in which you have to pass the other number system based string. Along with that, you have to specify the number system. So here this is the hexadecimal equivalent of 1, 2, 3, 4, 5. Along with that, I am passing the hexadecimal number system. And you can see the output is being converted into the decimal equivalent string. Similar to that, if I pass the decimal or the binary equivalent along with the 2 as the binary number system, it gets converted into the normal decimal representation of the same. Okay, so this was very short and precise explanation about the different functionalities or functions available within the DW core numbers. After this, within the same session, we will be covering about the binaries function as well. So let me show you the preview of this as well. You have to just make sure like you are either importing the all available function from DW core binaries, or if not, the specific function you have to import. Okay. After importing the DW core binaries, I have created some other variables like where my binary equal to mule as binary converted value. There is a content variable which is reading a particular line break based content. Basically, this particular content line 1 slash line 2 slash line 3, something like that, and it is being specified in application slash octet stream format. Okay. On line number 8, there is a variable being defined which is being specified in base 64. This is a base 64 value. So I will tell you like what is the exact meaning of this. And I have specified the readable type as application slash octet string. Okay. So this is just the groundwork which we will be using in rest of our functions. So the first function is to convert the binary into hexadecimal. So my binary is this function which is passing mule as binary format. So it will convert into the hexa equivalent of it. So this is the hexa equivalent of mule. Okay. Now similarly, I want to cross check like whether the conversion was correct or not. So what I have done, I have copy pasted this particular string as an input to from hex. So what it is going to do, it will read this hexadecimal value and it will convert it to the binary equivalent. And you can see mule, it is the same which we have converted initially into the hexa. Similar to this approach, to base 64, what it is going to do, it is going to convert the binary string of mule into base 64. And this is the base 64 equivalent of same. Now, in order to cross check whether it was a correct understanding or not, what I have done, from base, I have declared a variable from base and I am passing this particular 2 base 64 converted value using application slash octet string. So output of from base 64 is same as mule. So it seems the conversion to and from is working perfectly fine. The last part is about write lines with and read lines with. So there is a an array starting from 1 to 5 and we are going to map line 1 and then we are writing the line within the UTF-8 format. So what it is going to do, it is printing line 1 line space index then slash n, that is the new line character, and it is been repeating till line 5 ends. Now having said that, when we try to read this particular content, basically, so I'm reading the content base. I have copy paste this particular output onto this content read, and the type is application slash octet stream as I explained earlier. And now I'm trying to read the line with UTF-8 format, and you can see the output. It is now is being much more easy to visualize like what slash n was actually doing. Last but not the least, I have used this show type as one of the placeholder just to cross check the type of or the what is the type of this particular content based variable. So it is showing me as binary. It may or may not be required, but just for the debugging purposes, I have used it. So with this, we come to the end of one another session of DW functions, which was covering DW numbers and binaries. I hope you like it, and thanks for watching.